Good evening children, welcome back, welcome to Yupp Master, the school foundation program. In the previous class or the last 3 classes or 4 classes, we have started looking into the classification of matter, okay, the physical classification we have come across. So before we start into the next topic or the comparison of the different matters, let me give you a small advice here. Since the Yupp Master is providing beautiful online classes for you for the foundation program, please inform your well-wishers to download the app, get in connected with the online classes so that you can enjoy the school foundation program. And Yupp Master is providing foundation from class 6 to class 10th. Even the classes are available through YouTube. You can also get in connected with the YouTube classes as well, okay, right. So we people are looking the classification of matter in chemistry, okay. So when you observe the physical classification, we have classified the matter into 5 categories and we have discussed the 3 main physical classification of matter: solid, liquid and gaseous state, okay. So we have gone through the characteristics of solid, liquid and gas as well. So let us compare before we go into the 4th and 5th states of matter, that is plasma and Bose-Einstein condensate. Let us first go and discuss the differences between the solid, liquid and gaseous states with respect to their physical as well as the other properties, arrangement of atoms, okay. So I can bring all the 3 states of matter at one position. We know in the case of gases, the gas when you take in a container, the particles are separated by large distances, and since they are separated by large distances, they are going to possess they will move freely, the gas particles will move freely and independently. So one gas particle is not influenced by other gas particle, okay, they have their independent movement. So they can freely move as well as they can freely they can independently move without the interaction of or without the affection or influence of other particle. So this is a picture of a gas taken in a container. Once the cap is opened, the gas particle starts escaping, okay. And let us observe that liquid in a container, if you are going to take, the particles are going to be arranged in a loosely manner, but of course they are little close compared with that of the gases. And when you observe the space that is present between the particles, very little compared with the gases, the space is present, and of course this is also more space that is available between the particles of the liquid. So the particles of liquid can move freely but not independently. Gaseous particles can move freely and independently because the separation of the particles is very large, okay. But in the case of liquid, if we observe, the particles can move freely but not independently. Why? In this case the separation between the particles is less when compared with the separation of the particles in the case of gases. For suppose if you are taking a liquid a solid, how the particles are arranged in a solid? In case of solid, the particles are arranged in a orderly manner. So since they are orderly arranged and tightly packed, you cannot find the gap between the particles. So the gap between the particles is very small, very little space is present, very little intermolecular space is present between the particles of a solid. But in the case of a liquid, the space increases a little, and in the case of gases, the gases will have very large separation. Since the large separation is possible, here gases can move freely and independently. Very small separation is present between the particles of the liquid, so the movement is little restricted. They can move freely but not independently. But in the case of solids, the separation between the particles of the solid is very less, very little empty space. Little empty space is present, so the particles cannot move at all. So movement of particles is not possible in the case of solid. You can take, for example, if you are keeping a bowl of sugar at one position, or if you are pouring the bowl of sugar on a table, can it move? No. but if you are pouring one glass of water on the table, automatically the water will move toward the downside, okay, tilted area, okay. And whereas if I are taking a glass of air and making to keep it on the table, will it remain on the table? No, it will escape easily. Why? Because of the movement, okay. So these can diffuse, gases can diffuse easily, liquids can pour or it can flow easily, but solids does not have that ability, okay. Now let us compare the properties of these three states of matter with respect to the arrangement of the particles, arrangement of the molecules, arrangement of the atoms within the given physical state of matter, right. Let us see first. So here I have taken parameters in this column: solids, liquids and then gases. So we are going to compare one parameter in all the three, and then second parameter and third parameter, etc. Okay, right. So when you look at, when I take the parameter as a packing of molecules, when I look for the packing of molecules, how the molecules are packed within solid, liquid and gas. If I am focusing on that area, you can clearly observe in the case of solid, what is happening? The particles are closely packed, very closely packed, they are very close enough, they will come closer and the packing is taking place in a ordered manner. So packing is very, very close in the case of solids. Coming to the liquids, in the case of liquids, they are not closely packed, but they are loosely packed. This is in the case of solid, the particles are closely packed, tightly packed, whereas here in the case of liquids, the particles of liquid are loosely packed, loose packing is available, okay. And in the case of gases, if we observe, they are very loosely packed, still the packing is very loose. So you can observe the arrangement of particles in the case of solid, liquid and gas at one place. Here they are closely packed. In the case of solid, the packing of molecules is very, very, very close enough with one another, tightly packed, whereas in the case of liquids, it is not close packing, it is loose packing that is possible. So the particles of liquid are loosely packed. Here if we observe in the case of gases, the gases are very loosely packed, still the packing is very loose, okay. So this is how the packing of particles or the packing of molecules we can observe from the first parameter comparison between solid, liquid and gas. Now let us move on to the second parameter. What is that? Intermolecular space. Intermolecular space means the space that is available between the particles. We know in the case of solids, the solids are arranged in a tightly, closely packed manner. So can we expect any gap between here? The gap between the particles, if I observe the gap here, the gap is very, very less. So the gap is very small in the case of solids in their packing, okay. Let us take in the case of liquids. So if you observe the liquids, so you can clearly observe in the case of liquids that the separation is possible, and moreover the distance is possible in the case of liquids. So the particles of a liquid, if you observe, they are separated by, they are loosely packed and separation is possible. Similarly, if you are taking a gas, okay, in the case of gas, if you see the separation between the particles of gases is very, very large. So separation between the particles of gas is very large, okay. So this is the space that is present between the particles is generally called as intermolecular space. So between the molecules we have space, so that is known as intermolecular space. Empty space that is present between the particles of solid or liquid or gas is taken as intermolecular space or interparticle space, right. How the interparticle space can be seen in the case of solid, liquid and gas. So when you look at the interparticle or intermolecular space, here it is negligible. Negligible means very small. So, we can neglect the space between the particles. So, they are tightly packed, so they do not have any space between them. So, the intermolecular space is not possible in the case of the solids, first one, right. Coming to the liquids, less than that among the solid molecules. Of course, the intermolecular space when you observe, it is less when it is more than that of the solid particles and less than that of the gaseous particles. Okay. So, here the space when you compare the solid and liquid, the space is more in the case of the liquids when compared with the solids. And of course, when you look at the gases, what is there? It is the maximum among the 3 states of the molecule. Okay. It is maximum among the 3 states of the molecule. Within the 3 states of the molecule, if you observe, the separation between the particles is maximum in the case of a gas. So, when you take a gas, the molecules are separated by large distances. So, intermolecular space is maximum for gas and it is minimum, negligible space is present between solids, and liquids will have intermediate. They are going to have less space than that of the gases, but more space than that of the solids. When compared to the solids, liquids will have more intermolecular space. When compared with the gases, liquids will have less intermolecular space. So, that can be observed here with respect to the space, the area available, the space available between the molecules. So, we can clearly observe from these 3 figures that in case of gases the separation is maximum, and in the case of solids the separation is negligible, and in the case of liquids the separation is intermediate between the liquids and gases and solids, intermediate between gases and solids. Okay, right. So, this is regarding the intermolecular space that is available between the molecules. Okay. Intermolecular force of attraction, intermolecular force of attraction. So, when you observe the intermolecular forces, that is to say that in the case of solids, since the gap is not very less, so the attraction forces are more. Why the space is less? Because one particle is attracting the other. So, attractions are more in the case of solid. But when you look at the liquid, the separation is maximum. So, intermolecular interactions, attraction force is less compared with the solid. But when you observe the gas, what happens? So, between the particles of the gas, the separation is very large. So, automatically intermolecular forces are negligible. We can say that no attractive forces are possible in the case of gas, but highly attractive forces are present in the case of solid. What about liquid then? The intermolecular forces are intermediate between solid and gaseous state, right. So, intermolecular force of attraction, this is the attraction force that is present between the particles of the constituent matter. Okay. So, intermolecular forces of attraction when you observe in the case of solid, it is maximum. What is it? It is maximum. So, maximum intermolecular forces of attraction is present here in the case of solids. When you observe the gases, what is given? Negligible. So, it is to say that no intermolecular forces are present between the particles of a gas. Between the gas particles, attraction forces are not present, whereas in the case of solids, maximum attraction present. So, therefore, the particles are coming closer enough and they are tightly packed with one another. What about the liquids then? They are less than that of the solid molecules. The attraction forces are less than that of the solids, but more than that of the gases. In other words, we can say that in case of liquid, the intermolecular forces of attraction, the attraction force between the particles of the liquids are less than that of the solids, but more than that of the gases. In other words, the liquid molecules will have intermediate intermolecular of attractive forces compared with the solids and gases. Okay. So, that way we can compare the properties of the intermolecular force of attraction between solid, liquid and gases, right. Okay. Then let us move on to the one more property, that is the movement of the molecules. How the movement is possible between the molecules of solid, liquid and gas. Okay. Generally whenever we see the anything, any solid or any liquid, any gas, the particles will not be in a constant position. They won't sit in a particular area with a constant position without any disturbance, but the particles will move here and there. So, the vibration is possible. So, the particles will have a vibrations within them, and how the vibrations are going on? They are vibrate to and fro about a fixed position. The position of particle is fixed. In the case of solid, since the separation is very less, and the particle will vibrate. Here the vibration is possible within the given area. Within that area, the vibration is possible for the atom or the molecule of the solid. Okay. So, within the fixed position, the particle of solid will vibrate to and fro. So, to and fro vibration is possible within a fixed position. Within that area, start like this way the particle will vibrate, okay, in the case of solid. But what is in the case of liquid? Vibration is possible to and fro between the particles, okay, within the particle this vibration is possible. Along with that, what is happening? They rotate around their own axis and move from one place to the other place within a certain limit. Here the movement is not possible, only the vibration is possible in the case of solid particles. But in the case of liquids, vibration is possible and they can move also. Okay. Where they can move? They can move from one to the other place within a limit range. Within the limit, they are going to move from one place to the other place. Then what about the gases? In case of gases, if we observe, they vibrate to and fro. Vibration is possible in the case of gases also, and they can rotate around their own axis and they can move from one place to the other place in a random fashion. There is no restriction at all. They can move in all the directions that are possible, and moreover they can move with a higher speed than that of the liquids. So, when you take the solid particles and liquid particles as well as the gaseous particles, as the distance separation is increasing, in the case of solids, since their particles are closely packed, so they cannot move away from that position. They stay in that position, and but they can move like, or they can vibrate. So, the vibration is possible here and it is going to be in a fixed position. The position is not going to change. But in the case of liquids, here the particle will move on its own, okay, in that position it will move. Not only the vibration, but even it can move within a certain limit with some speed, okay. But when you observe the gaseous particles, in the case of gases also the vibration of the atom is possible. Within that particular molecule the vibration is possible. With that it is going to rotate and it is going to move from one area to the other area with high speeds compared to that of the liquids. So, when you look at the movement of the molecules within these three states of matter, solids will vibrate to and fro in a fixed position. Liquids will vibrate to and fro, and that along with that they are going to have a rotation about their own axis. Okay. When you observe the gases, they have the vibration, they are going to vibrate to and fro, they are going to move from one place to the other place, but in a random fashion. It is not fixed in one direction, and moreover with a higher speed. The speed with which the gas molecule is moving is very high when compared with the speed with which the liquid molecule is moving. Okay. So, this is how we can compare the arrangement of the molecules within the solids, liquids and gases. Okay. Let us also observe some more properties of the gases, liquids and solids. Okay. So, we know the gaseous arrangement, liquid arrangement and solid arrangement can be seen here. So, just look at once again the arrangement of particles in these three states of matter. Okay. Now, let us compare the physical properties of matter for the solids, liquid and gases. What are the physical properties? Mass is a physical property, weight, mass means weight, okay, and volume is a physical property, shape is a physical property. So, we can compare the physical properties for these three different states of matter, right. Mass if you take, solid will have a definite mass. Solids will weigh, it is going to have some mass, no problem, right. Liquid also, if you take water in a jug, if you weigh it, it is going to possess some weight, okay. Along with the weight of the container, the liquid also will have some weight, water will have weight. So, weight is possible, the mass is possible. So, solids will have definite mass, liquids will have definite mass, even gases also will have definite mass. Mass also possible for gas as well. As I told you in the previous classes that when you take two balloons with a different amount of air, so the balloon with the having more amount of air will be more weight compared with the balloon with having less amount of air. So, automatically we can say that gases will have definite mass, they are going to possess. So, all the three states of matter, whether it is a solid or liquid or gas, they are going to have mass, mass is possible. So, all the three states will have definite mass, first thing, right. Let us look at the volume. Solids will have definite volume, as we have seen in the previous diagram. For example, if I observe this one, so here if you see the definite volume is possible for this one, definite volume is possible for the liquid as well, but here the definite volume is not possible for the gas, okay. So, here you can clearly observe that the solids will have definite volume, okay. Liquids will have definite volume, liquids and solids will have definite volume, but gases, they do not have definite volume. Definite volume is not possible for gas, okay, right. When you take the shape of the solid, liquid and gas, since the particles arrangement in the case of solids is closely packed and molecules cannot move, in that case they are going to have definite shape. Definite shape is possible for solids, okay. Whereas, if you look at the liquid, do liquid have a definite shape? In the previous class we have discussed, when liquid is taken into different containers, generally liquid will take the shape of the container in which the liquid is stored. So, liquids, they do not have definite shape, okay. When you observe the gases, gases also do not possess definite shape. So, definite shape is possible only for solids, okay. Definite volume is possible for solids and liquids, definite volume, okay. Gases, they do not have definite volume, but when you take the mass, that is weight, all the three, solid, liquid and gas, possess definite mass. Definite mass is possible for all the three, okay. Definite volume is possible for solid and liquid only, not for the gas, okay. When you look at the shape, definite shape is possible only for solid, no shape, definite shape is possible for liquid as well as gases. So, from these properties if you observe, we can make one conclusion that solids will have definite mass, definite volume, definite shape. Solids will have definite mass, definite volume, definite shape. So, shape is possible, volume is possible, mass also possible for solid. But when we look at the liquids, liquids will have definite mass and definite volume only. In the case of liquids, definite mass, definite volume is possible, but no definite shape. So, only two parameters are definite, that is mass as well as volume. That is to say that they have fixed mass and fixed volume, fixed shape is not possible, whereas solids will have fixed mass, fixed volume, fixed shape. Mass, volume and shape all are fixed for solid, but in the case of liquid, only mass and volume is fixed, but not the shape, because the liquid is going to take the shape of the container. So, it is not fixed, shape is not fixed there. So, no definite shape in the case of liquids. But in the case of gas, if I take, if we are going to observe the gaseous, in this case gases will have only definite weight, only definite weight is possible for gases, or definite mass is possible, fixed mass is possible for gases, but no definite shape and no definite volume. Volume and shape is not at all possible for gas, but in the case of liquids, mass and volume is possible, no shape. But in the case of solid, mass, volume and shape all are possible, all are fixed for solid. If I take a wooden piece will have a fixed shape, right, and it is going to have fixed mass, the weight will be fixed, and when I throw it on the earth or the ground, what happens? It is going to occupy some fixed value. So, all are fixed. For example, if I take water will have a fixed mass, I can weigh it, it will have a fixed volume, I can measure it in terms of liters, but if I take it in mug, it will be taking the shape of the mug. If I am throwing on the ground, it will flow, so it will be, the shape will be different, so it does not have a definite shape. But when I take air will have, when I fill the balloon with the air, the balloon will weigh, mass is possible, it will have a fixed mass. But if I am going to change into the different vessels and different balloons, shape is not possible, volume is not possible. So, no fixed volume, no fixed shape, but only fixed mass is possible for the gases. Okay, students, I think you have come across and even identified the different differences between the matter, the two, especially solid, liquid and gases, and I think you have enjoyed the class, and we are going to see some more concepts of matter, the classification, physical classification, as well as some more concepts in the next class.